Today we're looking at problem 26 and 27, and it says a radioactive element decays at a rate of 5% annually. There are 40 grams of the substance present. How much of the substance remains after 30 years to the nearest tenth? I'm going to read it again, looking for potential information. The element decays at a rate 5% annually, and we know that we have 40 grams at the beginning. 40 grams are present. So we're going to use our two exponential growth and decay formulas. And it says we have 40 grams. That's the amount that we have in the beginning. We begin with a 1, and it says we decay. So since we decay, we're going to lose, and we're going to lose 5%. So be careful with 5%. 5% is 0.05 raised to the x, and on our problem, x is time because it's looking at the number of years. So this is really time, or this is your x. Look at the other equation. We still have 40, but the b value is taking 1 minus 0.05, and it's going to be written as 0.95. So our b value, or growth or decay factor, in this case, the decay factor is 0.95. So let's go to the calculator again. You'll notice that I have typed both equations into the calculator. So we're going to change. Let's go back over here and graph this. I want you to notice, let's see if we can even get it to graph. We cannot, so think for a second, if you're sitting at home, why is my graph not showing up? What's wrong? Okay, look, you're beginning with 40. If you look at your graph, mine only has 10. So we need to change our window. So read the problem again. We're talking about a 30-year decay. Time is your x. So let's go ahead and go from 0. We're going at least 30 years. And it says you have 40 grams, and you're going to lose some, but if you want to see the whole thing, sometimes I'll round up a little bit. So I'm going to go to 50. So let's hit graph. Now watch, you should see a red line and a blue line. See what happens. So what this tells us is the blue and the red, they're both the same equation. One is just in a little different form than the other one. So if it doesn't matter, I'm going to take one off. I'm going to hit clear. Hit graph. Again, we have a decay. You had 40 grams, and every year you're losing 5%. So the question was, to the nearest tenth, what do you have after 30 years? So let's go look at the table. 30 years. Let's go back up first. Excuse me. Go to, in the beginning, you had 40. You're losing 5%. So if you would take 0.05 times 40, you would get 2. So we're losing 2 that first year. So you keep on going to 30 years. And so we have 8.58, and it told us, I believe, to round to the 10th. So that 8 rounds the 5 up. So the answer to 26 is, let's go back and look again, is 8.6. 8.6. So we are losing, so we have 8.6 grams left after 30 years. Let's read question 27. When will the amount of the substance drop to below 20 grams? So let's go look in the calculator. When does it drop below 20 grams? Well, is it year 12 or is it year 13, or how do you know? Let's go back to the graph. Sometimes when my y value does not have the value they want, I go back to my calculator and type in, when is my y value going to approach 20? Hit graph, and we're going to see the red line and the blue line intersect. So we're going to go second calc, intersect, hit enter, enter, enter. So what year is it? By the 13th year, roughly around the halfway through the 13th year, we should reach 20 grams. So what year is it? The answer is the 13th year, year 13. Hope that helps.